generally choose it more on the basis of things like community or the packaging system that they prefer, or certifications, or sort of other reasons. So by creating more harmonization and more commonality in the cadence of the upstream projects, will make it easier for the distributions effectively to almost accidentally end up with similar versions of the kernel, similar versions of Firefox, similar versions of X, OpenOffice, GCC, and so on, and therefore make it easier for us to collaborate with multiple distributions. With the next release of Debian, we'll have a collaboration across a couple of major pieces of infrastructure. It looks like we'll have the same version of the kernel. It looks like we'll have the same version of X. It looks like we'll have the same version of GCC. It looks like we'll have the same version of Python, although that's not so sure. So I'm very positive about how that's emerging, and think that that's going to really sort of improve the level of collaboration across the whole ecosystem. So the second area that I wanted to talk about was the way we think about quality. Now, in the free software ecosystem, we take great pride in our software. I think many people have pointed out that when a developer is writing software and they're writing it under their own name, they know that their friends will be able to see their code. It won't just be hidden away behind, a compiler. That results in more personal pride going into the software. And when people take care of the software, you get better quality software. Many people have made that argument. Many people have also made the argument that the fact that the software is open source means you have more visibility of bugs and you have more places where fixes can come from. So that should lead to better quality. But I think there are still additional practices that we can add to the free software process that would improve quality even further. When we started to work at Canonical, when we started to work with consumer electronics companies, people who were shipping PCs with Ubuntu, we realized that they had these big teams of people who test everything that they send out from the factory. And in starting to work with them, we realized that actually there's great benefit in having very rigorous testing of the software that gets produced. And so we're now starting to try to work with starting to try to work with the community with Ubuntu to publish standardized test programs for each release of Ubuntu, so that people can participate in making sure that it actually behaves in a predictable way. We're also starting to encourage upstream projects to embrace more rigorous testing, so that when Firefox ships, for example, or when OpenOffice ships, they can go to the community and say, if there are 100 people out there, if you each just test these 10 things, we will know for certain that at least 1,000 things work the way they're supposed to work in this release of OpenOffice. So I think there are really interesting ideas to be explored in combining sort of formal QA, quality assurance, with crowdsourcing and community and open source processes, where we effectively reach out to very large groups of people and ask them to collaborate on quality. Another practice that I have become a strong proponent of is the use of automated testing. So automated testing is when in the code itself, or alongside the code that you're producing, you write a second set of code which effectively tests the function calls and the behavior of the software that you've written to make sure that that function is still behaving the way it's supposed to. So the idea is that you would write a piece of code, a function, and then you would write another piece of code that's sole purpose is to call that function in lots of different ways and make sure that the result of that function call is what you would expect it to be. And so this second piece of software is called the test suite. And we're now starting to see more and more projects that actually ship with the test suite. What that means is that you can go download the source code, and when you download the source code, you can make it, but you also, when you're making it, you make the test suite, and then you can run the test suite. And this is a wonderful asset because it allows people very quickly to establish whether a change in the code has broken core assumptions that other people might be making about the code. Now, when you dive into this, there are all sorts of different ways to do it. Some people believe, for example, that you should actually write the test suite before you write the software. because the test suite, writing the test suite helps you clarify your understanding of how the software is supposed to behave, and then when you write the software, you know that it's actually behaving, it's actually doing what you set out to achieve. But that's quite extreme. Other people take the view that it's okay as long as when you know, it's okay to write the code first and then write the test suite. As long as when you land your changes, when you actually commit the changes to the project, it comes with the changes and tests for the changes. That way, over time, slowly, the project grows more and more tests. It gets more and more rigorously tested. It gets easier and easier to measure the quality of the software objectively.